Hey, Sis Gray, welcome to our skill practice lesson for today. Remember, this skill practice is based on the work we did yesterday on Unit 3, Lesson 11, which was combining like terms. So I know this may have been slightly confusing. We're going to get another chance to kind of get another at bat to give it a little bit more practice. And hopefully the way I explain it today makes a little bit more sense and clears up any confusion that you may have had when you were going through yesterday's lesson. So before we get started, let's go and talk about the objectives that we'll be doing today. So there's really three things that we really want to focus on to be successful, not only in the skills practice, but to be successful on what we did yesterday. The first thing we need to be able to do is to identify like terms. We need to understand what like terms are, what do they look like, how can we tell them apart? Because once we do that, that'll really be the foundation of how we become successful today. If we can identify like terms, that really is going to help us with the rest of our work. Once we can identify like terms, we need to be able to combine like terms. And we do that through addition and subtraction. Specifically in sixth grade, we only really worry about combining like terms through addition and subtraction. As you get to seventh grade, you'll be doing a little bit more complex combining. But for the purposes of this year, you just have to worry about using addition and subtraction to combine like terms. And if you don't know what that means, you'll get it. I'll be able to show you here in just a second. And then the last thing that we will do is we'll put it all together. You need to be able to identify the like terms and combine them to simplify expressions. Remember, the word simplify means to make as small as possible. So I'm going to take this really, really long expression. I'm going to make it as small as I possibly can by combining terms that are the same, that are like terms. All right. That is our goal for today in this video that we're going to be doing here in just a second. All right, so let's get into it. There really is only three different terms that you will see in an expression. You will see numbers. These are all like terms. So numbers that don't have any variable or any exponent are considered like terms. Those are like 3, like 4, like 5. Anything that is just a number is considered a like term on itself. The numbers do not have to be the same for them to be like terms. They just do not need to have a variable or an exponent. Then we have two other like terms that I really, really want to focus on. Notice as you look at our three different terms as the description at the top, it just says variable and exponent. Remember that the number in front of our variable is called a coefficient. We do not need to have coefficients that are the same to have like terms. Those numbers do not matter. The only things that I'm looking at is my variable and exponent. Okay, that determines whether they're like terms or not. The number in the front of that variable does not matter. All I want to focus on is, are my variables the same, or is my variable and exponent the same? As you can see here, when it comes to a number that has a variable, so we have a coefficient, a number in front, and a variable, I need to make sure for them to be like terms that they have the same variable. So for example, 3w, for it to be considered a like term, I need to find another term that has a w as a variable. So 4w would be a like term, 2w would be a like term. Anything with the variable w will be considered a like term. Remember, we only want to focus on, are my variables the same? If they're the same, they're considered like terms. The next one is the variable and the exponent. You will see terms that have a variable and an exponent. When it comes to these terms, once again, we're not focused on the number in front. We're only focused on our variable and our exponent. For these to be like terms, your variable needs to be the same. So I need to have a term that has an a as a variable, but also your exponent needs to be exactly the same. So not only does it have to be an a, but it has to be a to the second power. If it was 3a to the third power, this would not be considered a like term because the exponent is not exactly the same, even though my variable is the same. My variable and my exponent need to be exactly the same, which means for it to be a like term, it needs to have an a and an exponent to the second power. These are like terms because they share the same variable and share the same exponent. So remember, these are the three different terms you will see. You will see numbers that don't have a variable or an exponent. All the numbers that don't have a variable or an exponent are considered like terms. You will see a term that has a number and a variable, as you see here, a coefficient and a variable. In this case, when you see just a number and a variable, they need to have the same variable to be considered a like term. And then you will see a term that has a number, a variable, and an exponent. For them to be like terms, the variable and the exponent have to be exactly the same for them to be considered like terms. Let's go through some more examples. We're going to really focus on the variable terms and the variable and exponent terms just to get an idea. So remember, when we have a term that has a variable, the variable has to be the same. So for example, if I have 2y, the only terms that are like terms to 2y are terms that have y in it. So 3y, 4y, 6y, 100y. As long as it has the y in it, they are like terms because they have the exact same variable. This is also not to be confused that if it was 2y to the second power is not a like term, because I just need the variable to be the same, and because my y does not have an exponent, neither can my like term. So it only has to be terms that have just a number and the variable y, as you can see here. Because we can see here that variables and exponents are considered different terms. So variables, terms that just have a variable are one term. Terms that have a variable and exponent are a separate term. They're not the same thing. They're two different terms. And once again, when we're working with terms that have variable and exponent, like 3n squared, for them to be considered like terms, they need to have the same variable and the same exponent. Okay, so for example, I have 3n squared, so like terms would be 4n squared, 9n squared, and like I said before, even 100n squared. And I know they're like terms because they share the same variable and the same exponent. And just to repeat, even if they just share the same variable, that's not the number one to put down, sorry. Even if they share the same variable, but not the same exponent, they are not like terms. They must have the same variable and the same exponent to be considered like terms. This is the basis, all right? If you can identify like terms, you will be able to do the work today. So once again, we have three different terms. We have numbers that don't have a variable and do not have an exponent. All those are considered like terms. We have terms that have a variable, like 2a. For them to be like terms, they all must just have the variable a, cannot have an exponent, just the variable a, because we want them to include just the variable. If they have an exponent, they're considered a different term. Then we have terms that have variables and exponents, and they have to have the exact same exponent and the exact same variable to be considered like terms. Let's get into what it means to combine like terms. So when we're combining like terms, this is just a lot like adding and subtracting. For example, once we know that we have like terms, as you can see here, we know these are the same terms because they both share the variable a. We can combine those two terms. 2a plus 3a, and it comes down just to our regular math. 2 plus 3 is just 5a. Let's do another one. 3y minus n. I cannot do this math because they are not like terms. I cannot combine them. This is a y and this is n. They are not like terms, cannot be done. But I can do 3y minus y. Remember, anytime you see just a variable by itself, it technically means just one y. So 3 minus 1 equals 2y. The same applies when we're working with terms that have variables and exponents. So let's say I had 4k to the second power plus 2k to the second power. I know they are like terms because they share the same variable and the same exponent, which means I can combine them, and that just means doing the math. So once again, I just do my normal math. I have 4k to the second powers and I have 2k to the second powers. So if I put them together, I have 6k to the second powers overall. The same thing works when it comes to subtraction, as long as they are considered like terms. So for example, let's say I have 5n to the third power minus 2n to the third power. I'm just going to go ahead and do my math. 5 minus 2. They are like terms. They have the same variable and the same exponent. 5 minus 2 is just 3n to the third power. Notice how my term stays the same. We want to make sure the reason we can combine them is because they are the same term. They will stay the same because they have the same variable and the same exponent. The only thing that's changing is how many of them we have. I had 5 n to the third powers, I took away 2, now I only have 3 n to the third powers. I had 3 y's, I took away 1 y, now I only have 2. But the y's stay the same. What makes the term is the variable or the variable and the exponent, which is why we can actually combine them in this manner. So now that we have an understanding of how we combine them using addition and subtraction, let's kind of put it all together, as you can see here. So we want to simplify this expression. We want to make it as small as possible. The first thing I want to do is identify like terms. When I'm identifying like terms, I also want to include the operation that's in front. So as I go through this is going to be the first model. The next ones you have a chance to do on your own. I have 5a. So I want terms that have just an a as a variable that I want to circle. So 5a, excuse me. So 5a is a term. 19 is not the same term as 5a. It doesn't have a variable. 2a is because it just has a variable a. I want to include the subtraction sign. And then 10z is not a term, 9z is not a term. Perfect. Okay, so let's go to the next term. I'm going to pick a different color to represent my different terms. So I have 19. Here I have a plus 19. I want to include that as well. Is there any numbers that don't have a variable and don't have an exponent? No, this one has a variable z. This one has a variable z as well. All that's left, the only term that's there is just the 19. Let's go to our last one. So I have plus 10z. And I have, oh, yep, here I want to have any term that has a z in it, just a z. So minus z is my other term. Now I want to combine it. So I want to make sure I combine my 5a and my minus 2a. That's why circling the operation in front is important. I want to know what math I'm doing. In this case, I'm subtracting 2a. So I have 5a minus 2a, which is 3a. Okay, so there I combined these terms already. I know that 19 is just going to stay plus 19. Nothing changes from that. Then I want to do the last part, which is 10z plus 10z minus 9z. Well, plus 10z minus 9z is just z, or 1z, because I can subtract 10 minus 9. And here I have my combined terms, 3a plus 19 and 1z. When I'm writing these out, I'm going to write them out just as I see them. So I have 3a plus 19. Because this is a positive number, it's not a negative, I'm just going to put a plus sign in front, plus z. Here's my simplified expression. Remember, simplifying means taking a very large expression and making it smaller. I'm sorry, you can't even really see that. I'm going to write it here on top. So it's 3a plus 19 plus z is my simplified expression. Look at how I went from this really long expression to an expression that just has 3 terms in it. Identify that it had 3 terms first. I combined them, rewrote my expression in a simplified manner. Let's go to the next one. Go ahead and pause here, and I want you to try this one on your own before I go over it. All right, let's go ahead and combine some terms. So I know I want to combine terms that have b to the second power. Okay, this term doesn't work, has a c. This one does work, minus 2b squared. And then that's all I see. We go to the next one. Okay, so I want terms that have a c in them. Remember, I'm also including the operation in front. 10 is just a number, can't do it. But here's my plus c, definitely can do that. And then do I have any other numbers without variables or exponents? I do not. All I have left is 9a, which is a term on its own because there is no other a's. So I want to go ahead and combine the terms that have more than one term in it, more than one like term. So 3b squared, I want to do 3b squared minus 2b squared. Remember, I figured out what math I'm doing by looking at the operation in front of my term, which gives me just b squared. I want to combine my c, so I have 4c plus c, which equals just 5c. And then as you can see here, I don't have anything to combine the 10 with, and I don't have anything to combine my 9a with. So those stay exactly the same. So when I write my expression, I'm going to include all this. So it should be b squared, because my 5c is a positive, it's going to be plus 5c plus 10 minus 9a. And there you go. There's our new expression. Sorry you can't see that, but that's supposed to be an a. minus 9a. All right, let's go through our last one. Once again, pause the video here, try this out on your own before I go over it. All right, let's quickly go over it. So I want to make sure that I combine and circle any terms that have no variables and no exponents. I see a minus 7 here, so I'm going to go ahead and circle that with the subtraction sign in front. Got that. So now I see a minus n squared. Do I see any other n squares? I do not. Then I have 4w. So I want to make sure I circle terms that have a w in it. Oh, I see one here, plus 8w. And then my last but not least is just n to the third, which is a term by itself. I'm going to go ahead and combine it. So I have 12 minus 7. So 12 minus 7, that's going to give me 5. So I have 5. Then I want to combine, well, I can't combine my n squared, so that's going to stay the same. I can combine my 4w and my 8w, so I have 4w plus 4w plus 8w, which just means addition, which will give me 12w. So I'm going to put plus 12w. And then last but not least, I want to include my last term, which is n to the third power, which doesn't have an actual another term to combine it with, which is just plus n to the third power. So as you can see here, here is my simplified expression after I've combined my like terms. Remember, if they do not have another term to combine with, you leave it as it is. So I was a minus n to the second power, it stayed minus n to the second power. There's nothing else for me to combine it with. Same thing with my plus n to the third power, nothing to combine it with, it stays plus n to the third power. The only thing I combined are terms that had more than one like term. So the 12 and the 7, and then the 4w and the 8w. This is the work you'll be doing. If you need to come back and look at this video again, please do so. It's definitely there for you to go back to and refer to. So if there's a part that you're still not 100% sure on, go back, watch it again, and see if it makes more sense the second time. Good luck, Kipsters, in your work today.